Alright, so in this video we are going to start talking about our third way of solving quadratics. So far we've done root method, which only works when the variable is in one term, and completing the square, which works when the variable is in two terms. Today we're going to learn the third way, which is factoring. And with factoring you can use it when the variable is in two terms. So let's take a look. So we've actually already done factoring this year. Remember solving literal equations? A problem like this where we had to solve for g, but with the variable being in two terms, we were unable to do that. So what we did, and at the time we kind of called it reverse distributive property, is we took the g out of both terms. So if I take the g away from hg, I'm left with h. And if I take g away from yg, I'm left with y. And I essentially undid the distributive property. Because if I were to go ahead and redistribute g to h, I would get back to hg, and g to y, I would get back to yg. So these two are equivalent, it's just they're written in different ways. And so this is called factored form. So we've actually already dealt with factoring this year. So I just wanted to show that. I'm not going to keep solving it. So let's take a look at how factoring works. So the first thing we're going to be doing is factoring out a GCF. And if you remember, GCF stands for greatest common factor. So we're looking for something that multiplies into both terms, or something that both terms are divisible by. So the GCF for the first binomial, 16 and 20 both have a factor of 4 in common. And x squared and x, well, x squared is really x times x, and x is 1x. So if I look at both of these, they both have an x in common. So I'm going to take out 4x. I'm going to factor out 4x. And what I'm left with, 16 divided by 4 is 4. And if I take this 1x away from x squared, I'm left with x. And then 20 divided by 4 is 5. And if I take away an x from x, there's no variable left. And I always like to redistribute this to make sure I did this correctly. So 4x times 4x is 16x squared. 4x times 5 is 20x. So that tells me that this is my factored form. Okay, so for the next one, let's see what our GCF is. 50 and 20 both have a common factor of 10. And then y to the fourth is y times y times y times y. Y squared is y times y. So they both have y squared in common. And when I factor that out, 10 out of 50 leaves me with 5. Y squared out of y to the fourth, well, I took squared away, so I'm left with 2 more y's, y squared. And then 10 out of 20 is 2. These y's are gone, so it's just 2y, or just 2. And then if I redistribute it, 10y squared times 5y squared is 50y to the fourth. 10y squared times 2 is 20y, so we know that that's the correct final answer. So before, on that last page, we were just factoring. We weren't actually solving yet. In order to solve, we need to use the zero product property, or the ZPP. The zero product property is really straightforward. We pretty much have been dealing with it our whole lives in math. And it says if a times b equals 0, so if two numbers multiply to equal 0, then either a equals 0 or b equals 0. One of those two numbers must be 0. So for example, down here, this is in factored form. So this is called factored form. As we've seen it already, it looked a little bit different because we only had a monomial times a binomial, but here we have a binomial times a binomial, but it is in factored form. And if we're going to look at this as a times b, So we have one thing times another thing. So the zero product property says that if one thing times another thing equal up to 0, then either the first number or the first thing is 0 or the second thing is 0. So it's going to kind of almost look like our absolute value equations, where we're going to say either x plus 7 equals 0, the first thing, or 3x plus 1 equals 0. So either A equals 0 or B equals 0. And if we solve this, for the first one, I'm going to subtract 7 from both sides. I'm going to get x equals negative 7. And then for the second one, I'm going to subtract 1 and then divide by 3. So I'm going to get x is negative 1/3. So those are my two answers. And then if you think about it, this is a quadratic because x times x is going to be x squared. So we just solved a quadratic that was in factored form. All right, for the second example, we have A and we have B. So two things are multiplying to equal 0. So either the first equation equals 0 or the second equation equals 0. So let's see what two answers we get. 6x equals 0. If I divide by 6, I get x is 0, so that's my first answer. And then the second one gives me 2x plus 5 equals 0. I'm going to subtract 5 and divide by 2. So my other answer is x is negative 5/2. So those are my two answers there. So when we're solving quadratics, it's very important that the equation always equals 0. Because we want to use the zero product property, we're not going to be able to do that if the equation is not equal to 0. So when solving a quadratic by factoring, it's very important that the equation always equals 0. Otherwise, we're not going to be able to use the zero product property. So in the case of the first problem, that is already equal to 0, so we are ready to start factoring. So we want to find the GCF of 6x squared plus 8x. So a number that goes into both of those would be 2, and both terms have a factor of x. So taking a factor of 2x out of 6x squared leaves me with 3x, and taking a factor of 2x from 8x leaves me with 4. And again, we can always redistribute to make sure that works out correctly. So 2x times 3x is 6x squared. 2x times 4 is 8x. So we did factor it correctly. And so now that it's in factored form, we can use the zero product property, which says if something times another thing equals 0, then either the first thing equals 0 or the second thing equals 0. So that gives us our two equations that we can then solve for x. So here I can divide both sides by 2. Remember, it's okay to divide 0 by a number. And so 0 divided by 2 is 0. Here I'll subtract 4 from both sides. I'll get 3x equals negative 4. Divide by 3 and get x is negative 4/3. So those are our two solutions, and a lot easier than trying to complete the square. And then for this last one, it is not in the correct format yet. So what we need to do is we need to get it equal to 0. So I'm going to start by subtracting 4x from both sides, which is going to give me 2x squared minus 4x equals 0. Now that the equation's equal to 0, I can take out my GCF. So the GCF of both terms is 2x, which leaves me with x minus 2. And again, let's redistribute to make sure that's right. 2x times x is 2x squared. 2x times negative 4, times negative 2 is negative 4x. And then we have ZPP again that we can use. So either 2x equals 0, which when I solve that gives me x equals 0, or my other factor, x minus 2 equals 0, which gives me that my second answer can be 2.